Assalamualaikum warahmatullahi wabarakatuh. Our group will be presenting about our project design. My name is Nur Iza Shahira binti Shamsul Anwar, TG19018. So I would like to start with the introduction. In this project, we are required to design a 4-bit synchronous counter using JKFF in the following sequences. We need to make the output sequences as follows. For group 10, 2, 4, 9, 7, 9, 11, 12, and 15. Our objectives are to achieve the sequences given by using JKF 4-bit synchronous counter. The second one, to understand more about arbitrary sequence counter and implement them in our design. JK flip-flop is basically a gated SR flip-flop with the addition of a clock input circuitry that prevents the illegal or invalid output condition that can occur when both inputs S and R are equal to logic level 1.
Hi, Assalamualaikum. My name is Nurul Anas TG19014. So I will explain about the synchronous 4-bit circuit that we built. The component that we use is basically JK flip-flop. We use 4 JK flip-flop because this is the synchronous 4-bit circuit. Next, we use DCD hex. This component is the LED that displays the 7-segment output that can come from 0 until 15, which is F. Next, we use digital clock and basic logic gate, which is AND gate and also OR gate. So, this is our full circuit design for synchronous 4-bit circuit. As we run the simulation, the output will be displayed starting from 9, and it is because we set 9 as the desired number. After that, the number will count accordingly, which is from 2, 4, 6, 7, 9, B, C, and F.
Assalamualaikum warahmatullahi wabarakatuh. I am TG19012, Naatira binti Ali. So now I will explain the truth table for this project. So first we need to find the DCBA for the truth table, and then through the DCBA we will find the QD, QC, QB and QA, which is the output. So for the, as you can see, the state transition diagram, we will get the output as 2, 4, 6, 7, 9, 11, 13 and 15. So for the truth table, the input for 2 is 0, 0, 1, 0. So the next input is 0, 1, 0, 0, which is 4, and after 4 we will get the output as 6, which is the input is 0, 0.
Hello everyone, my name is Lukman Hakim Yadin, TG19016. I will present to you guys how to simplify JK flip-flop K-maps. Firstly, we need to do a JK flip-flop truth table. This truth table I just took from the previous presenter. Output for our group is 2, 4, 6, 7, 9, 11, 13 and 15. So, the truth table will be contain only that number. For the next step, there are 8 K-maps. We need to separate each one. JKD, JDKD, JCKC, JBKB and JAKA. From each K-map, it will produce an equation. I will show you an image of JDKD K-maps. From this step, we need to group all the bits 1 to get an equation. For JD, we can summarize that JD equal to A plus B prime dot C prime, and for KD is CBA. For the JCKC, same, we need to group all the bit ones So for the JC is D prime B A prime plus DBA. For the KC is A plus BD. For the JB KB is C A prime plus DC prime and A. For the KB, C prime plus D prime times A plus D A prime. For the JA is equal to D plus C prime B prime plus CB. For the KA is DB. From the all equation, we can do a stimulation. So that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Anwar Afif bin Ismail, TG19015. I would like to present the discussion in this project. In this project, my group has been assigned to make a simulation of 4-bit synchronous counter using JK flip-flop that will display number 2, 4, 6, 7, 9, 11, 12, 15, and the counter will return to the number 9 for all undesired number. We allocated 4 bits from 0000 to 1111 to the above states, displaying the number from 0 to 15. So here the basic idea is to design the logic circuits that interpret the counter's different states and provide each J and K inputs with the logic levels by applying the transition table. We begin our project with constructing the state transition diagram and the truth table in order to identify the inputs for the JK flip-flops. In order to execute the required sequence, which are 2, 4, 6, 7, 9, 11, 12, and 15, we need 4 JK flip-flops. By using state table that we have constructed, we set JK flip-flops for each input and use 8 Karnaugh map from the truth table to identify the logic equations for each of the input, which are JD, KD, JC, KC, JB, KB, JA, and KA. From the logic equations, we constructed the JK flip-flops to the synchronous sequential circuit. The fact that this circuit is a 4-bit synchronous counter, so it means that the clock input of all the individual flip-flops within the counter are all clocked together at the same time by the same clock signal. So during the circuit construction, we have been carefully connecting all the components to the clock input together. That's all from me. Thank you.
So in conclusion, synchronous counters are so called because the clock input of all the individual flip-flops within the counter are all clocked together at the same time by the same clock signal. However, with the synchronous counter, the external clock signal is connected to the clock input of every individual flip-flop within the counter, so that all of the flip-flops are clocked together simultaneously, at the same time giving a fixed time relationship. In other words, changes in the output occur in synchronization with the clock signal. As synchronous counters are formed by connecting flip-flops together, and any number of flip-flops can be connected together to form a binary counter. A 4-bit decade synchronous counter can also be built using synchronous binary counters to produce a count sequence from 0 to 9. A standard binary counter can be converted to a decade counter with the aid of some additional logic to implement the desired state sequence. Thank you.